All right, section P3, we're going to talk about functions and their graphs. A lot of things we're going to talk about in this one. We're going to talk about the value of a function, domain and range. We're going to talk about piecewise functions, composite functions, and translating functions. So all things that we learned in Algebra 1, we've talked about in Algebra 2, we talked about in pre-calculus. They're all going to kind of come together, and we're going to do one problem. We can do one problem and encompass all of these concepts. So we'll dive right into it, the value of a function. If we give you f of x equals the sine of x pi over 4, can we find f of 4? So if you recall, to find f of 4, we're going to take that x value out and we'll replace it with a 4. So we're looking at the sine of 4 pi over 4. We can simplify that to just the sine of pi. Now we need to know our unit circle. Oh, I thought we were done with it. But if you remember, hopefully, maybe not, our points are cosine sine, or cosine theta, sine theta if you wish to be proper. So we're looking at pi. Pi is over here. We're looking for this point. That point is -1, 0. So we know the sine of pi is 0. And that gives us our value of that function. Our most favorite thing to do with functions, though, if you remember, was this f of x plus delta x minus f of x over delta x. Or some of us, and I think I taught it as well this way, f of x plus h minus f of x all over h. Yeah. All right, so what do we do with that? If we're giving you f of x equals x squared, can I find f of x plus delta x? And sure we can. We can take x plus delta x and replace it for all of our x's. So we have x plus delta x squared minus f of x is just x squared divided by delta x. And there's a reason we use delta x, and we'll talk about this later on as we get into calculus, but delta x stands for the change in x, so we're changing x by some value. Very important that you notice that and see what we're doing. So we're taking x and we're changing it by some value of x, some arbitrary value of x, squaring it and subtracting off the original function, and then dividing by that change in x, whatever value that was that we changed x in. Cleaning this up, we can go ahead and multiply that out, x plus delta x squared. We get x squared plus 2x delta x plus delta x squared minus x squared over delta x. If you recall, anything without a delta x should cancel out. In this case, it does. So we're left with 2x delta x plus delta x squared divided by delta x. Now we can go ahead and factor that numerator. We can take out a delta x. We're left with 2x plus delta x all over delta x. Our delta x's cancel, so we're left with 2x plus delta x. Extremely important that we're able to follow these steps and go through this, especially as we get into chapter 2, which is going to be our derivative definitions. So it's all going to come together, I promise. I promised you back then. I promise you again today. It will come back for you. Domain and range. Remember, domain is the x's. The range is the y's. So if we look at f of x equals x squared plus 2, hopefully, remember our parent graphs and our translations. We know that x squared plus 2, x squared is going to be a parabola. The plus 2 is going to translate it 2 units up. So there's our graph. So our domain is going to be all the x values. So if I come all the way here at negative infinity, I can come up. And this graph, remember, is coming out as far as we can go. So it's going to be negative infinity. It's going to come to 0 down and then go back up to infinity, or come out to infinity as well for the x-axis. So our domain is negative infinity to infinity. Our range, we have nothing down here. And as we work our way up, the first place that we have it is at this point 0, 2. So our range starts at 2, and it's going to continue because these two branches continue up to infinity. A couple of things to recall. We use parentheses to show that we cannot touch it. Remember, we cannot touch infinity. the 2, we use a bracket because we can touch it. We can get the value of 2 down here. It's very, very, very farthest point down, or the vertex of this parabola. So we can touch 2, so we give it a bracket, and then infinity again, we can't touch. So we use the parentheses. In example 4, we're going to get into a piecewise function. So we have the f of x equals x plus 3, if x is less than 0, x squared minus 1, if x is greater than or equal to 0. The first thing it asks us to do is to graph the function. I forgot my piece of graph paper with this one. That's all right, I'll improvise. You, however, are not going to improvise, right? You have that graph paper I asked you to get on the first day, and you're going to use it. All right, so the graph of the function, x plus 3, if x is less than 0. So remember last year we kind of put an imaginary line there. I'm going to do it very light because hopefully we're all familiar with that. X plus 3 is a linear function. We started at 3 on the y-axis. We know that we cannot equal 0, so we know it's an open circle from that point. We had a positive slope of 1, so from the left to the right, it's going to come up 1 and over 1. So it's going to look something of that sort. X squared minus 1, if x is greater than or equal to 0, that is parabolic. I'm going to start here at negative 1, and it's going to go up in a parabolic form. So there's the graph of my function. To find f of negative 1, I can do this one of 2 ways. If I draw a nice graph, I can go to the x value at negative 1, come up, and be able to figure out my value. Or I can figure out, where does it work here? Well, f of negative 1, that's going to be less than 0, so it's going to be in the first part. So f of negative 1 is going to go into that first part, which is negative 1 plus 3, or 2. Do not take that negative 1 and plug it into that bottom equation, or bottom portion, because it doesn't work there. If you gave me 2 and plug in negative 1, you would get a 0 there. If you gave me 2 and 0, that would be an incorrect answer. It's only 2. For part C, f of a squared plus 1. Oh my, what do we do with the a squared? Well, if you think about a squared, a is going to be a variable. It can be any number you want, but if I square it, it's always going to be a positive value, or 0. But if I add 1 to it, it's always going to be larger than 0. So I know that a squared plus 1 has to be larger than 0. So that a squared plus 1 has to go into that bottom part. So I get a squared plus 1 squared minus 1. And honestly, I would leave it just like that. Any computation is acceptable to leave. We've answered the question. We found f of a squared plus 1. We plugged it in, our answer. If, however, you want to multiply that out, be my guest. A squared plus 1 squared, we get a to the 4th plus 2a squared plus 1 minus 1, so we get a to the 4th plus 2a squared. If it's multiple choice, you would probably have to get to this final answer here that I gave you. Extended response, by all means, we leave it, we leave it, we leave it. And part D, domain and the range. Domain, notice from negative infinity to infinity, we can come up or down and touch any value we want. So negative infinity to infinity. My range as well, this branch is coming down forever, comes up to the 3. This branch starts at negative 1 and goes up forever, so we're going to have a little overlap actually. So our range is negative infinity to infinity as well. Just a couple more examples here. Let's see, given the graph of f of x and g of x, can we find f of g of negative 4? So we ask ourselves, what is g of negative 4? Remember, with a composite function, we always start with the inside first, and then we go work our way out. So g of negative 4, well, here's our g function. We go over here, 1, 2, 3, 4. G of negative 4 is negative 1. So then we're going to ask you, what is f of negative 1? F of negative 1 looks like it is 2. So f of g of negative 4 is going to equal 2. And there's your answer. Let's see, given the graph of f of x, can we sketch a graph of the function? So this is a translations. Maybe I should have put that up there, translations. And I didn't give you a graph of f of x, so let's create one. Let's do it together. What do you think? What kind of function should we have? I don't hear anybody. Anybody out there? Nobody's out there. You're not going to give me anything. All right. Let's give it a nice, maybe absolute value graph. So f of x plus 1, what does that mean? So this is my f of x function. So what is f of x plus 1 going to look like? Remember, when I add 1 to a function, that raises the value by 1. The value we talk about is the y value. So I'm going to take each of these values and I'm going to move them up 1 unit. Should probably get a different color marker, shouldn't I? Should have thought about that. They're all the way over on the other side of the room. So we're going to have to deal with the red there, I guess. I'll label them so you can see it. So f of x plus 1 there. Well, f of x minus 2. Well, if I take that x minus 2 inside those parentheses, what does that do to my graph? And if you recall, we talked about this quite extensively in pre-calculus. By subtracting 2 on the inside there, we actually do the opposite, and that's going to affect the graph there. So f of x minus 2 is actually going to take this graph and it's going to move it 2 units to the right. So here's going to be that graph. So there's my f of x minus 2. And then part C, f of x plus 1 minus 3. So we're going to have 1 unit to the left and then 3 units down. So 1 unit to the left and 3 units down. That's going to be my vertex. And I have my nice absolute value there. And that's going to be f of x plus 1 minus 3. And that's going to take care of our translations. So a lot of things there. Go back and look at what you need to. Talk about a value of a function, piecewise functions, translations of functions, domain, range, all those good things. Good luck!